Alright, just waiting for things to go live. Alrighty, looks like we're live. Let's see, where do we want to put things? Alright, so hello everyone, welcome back to another stream, finally to another stream, now that everything is hopefully not wrong with me anymore. I'd had a bit of bout of food poisoning last week, was not pleasant. Some Halloween party, you know, I don't know. But anyway, so last time that I was streaming, it was a short stream. We cleaned up some of the errors that I made in deploying micro-ROS when I did the first micro-ROS stream, and namely that was what do you call it? Namely that was implementing. Since we were using FreeRTOS, it was enabling the enabling the FreeRTOS platform support in micro-ROS, or specifically in the data distribution system underneath micro-ROS, which is a micro XD XRCE, something like that, extremely resource constrained environment or something. Either way, all right. So we did that. We got that. We presumably got that working. We got it to compile. And it built and it ran, but we don't really have any other than it not crashing. We don't really have any introspection that it's doing what it's supposed to be doing. So I figured what we would do today, at least to start with, is implementing some performance metrics, implementing some profiling in FreeRTOS. So specifically, you know, if you used to using your computer, you know, and you've got HTOP if you're a Linux user, or maybe you've got, you know, system monitor or whatever you want to do to monitor your system, you know, usually you can expect to see, you know, if you're probably used to seeing CPU load or memory load or, you know, things of that nature. And with the Pi Pico, you know, we don't, or with the 2350 that we're using, we don't necessarily know. You know, it's not really running. I mean, it's running FreeRTOS, which is our operating system in this case. It's not really so much of an operating system as a kernel. But all right, the kitties are on the desk. For them, let's see. Hopefully they don't step on my keyboard again. Okay, so today, kind of what we're going to start off with doing, hopefully, is to implement is to enable FreeRTOS statistics, which is effectively going to give us statistics. So basically, hypothetically, FreeRTOS runtime statistics will give us effectively a load graph. You know, it will give us, you know, the amount of time that any given task is taking on the CPU. And for all I know, that I don't know how this lines up with multi-core usage, because maybe the percentages can add up to more than 100, you know, 200% for 2 cores. But the curiosity would be, or anyway, so I believe that the output of this, when you make the call, is a string. And so what we'll do is we'll add a, get down, there you go. I believe that the output for this is a string, so what we'll do is make send a ROS2 string message with essentially the contents of this display to our micro-ROS agent. At least that's the simplest thing I can think to do off the top of my head. And so we'll start there. Let me just make this bigger so y'all can see easier. So we'll start here. Try to do this, and hopefully won't spend too much time on it. And then after that, what we're gonna do is try to bring up some of the. Why is this showing errors. Let's just click compile, see what happens. Pico. No executables found for launch. No, I said compile. Wait, what went wrong here? Pico debug build all. Build Pico PyBot firmware. So we'll compile that. See if it. What is wrong? Let's see. CMake error. The current CMake cache is different. Oh, because I moved the folder. That's why it's freaking out. Okay, I put this in my a different tree, so it's going to not be thrilled. So yeah, we'll build PyBot firmware. Yep, it built again. Cool. That woo. I didn't break anything too deeply. All right. So let's see here. So yeah. So we're gonna. Shigua, get down. Don't. She's trying to bap the mouse cursor on the screen. So she's being very cute, but unfortunately, I don't want her to hurt my nice monitor that I have here. You know. Yeah. So we'll start with the performance statistics, the runtime statistics, and then what we'll do is, if you remember as well, we had to keep resetting the. We had to keep restarting the PyPico anytime we restarted the micro-ROS agent. So what we'll try to do as well is essentially, what am I even trying to say? We'll try to implement restarting the agent connection. Hi there. What are you doing? Yes. The kitties are like, wait, you were sitting at your computer, we were sleeping, and then you started talking, but you're not paying attention to us. So, what are you gonna do about that? There you go. Let's get down. There you go. Hey, don't eat the cable. Hey. They're now 6 months old, so they're entering as many a kitten owner has called it the T-Rex phase, and that'll last for the next 18 months. Anyway. So we're gonna start with runtime statistics. Publish it to a. No, you don't do that. Stop. Don't do that. Actually, maybe what we will do is we'll start with the agent reconnection because it's gonna get really annoying to keep reflashing this. So, you need to be good. Please be good. Please don't eat my cables. So we're gonna. So again, working on this ROS2 Robot. It's the thing in the thumbnail. I'm going to power this up, and the LiDAR spins up. The Pi's starting to boot. We will connect the debugger. Shigua, I put you down for a reason. No. I'm going to have to banish you from the room if you're not careful. You leave my stuff alone. So, okay. So, no. I tell her she's I can't say she's salivating looking at the cables, but she's trying to no. Don't attack wires. You were all nice and chill, and the moment I was clearly not paying attention to you, you went and started misbehaving. Okay. Let me get a cat toy here. Hey, look, play with the thing. Play with the thing. There we go. All right. So yes, runtime statistic. We're going to first look up the restarting the ROS agent connection. So my understanding is we've got, because what we do is the main first thing we're doing here is wow, okay. Actually, you know what we'll do here? We shall just commit the state of everything here. Yeah, git status, git remote. We don't have any remotes. We'll figure this out later. So you've added a git repository inside of your current. Oh, that's bad. Oh, I've really busted things. This is bad. Dependencies, Pico, I squared CT. Oh, shoot. Okay, well, I've just broken this. Get submodule add. You've added a Git repository inside your current. Oh, did I get modules? Ooh. Git. But I have the Git modules for cache dependencies. Oh, wait, no. Oh, Git. I'm gonna find Git reset dot. What was this other thing? Git rm cached. Well, that got cut off anyway. Module. No, sorry. Dependencies. Pico squared CDMA. Okay. Maybe I don't do that right now. We'll fix this later, I guess. That's unfortunate. Okay. So get her off me. She goes down. Okay. So reconnection. So essentially, all we do is we do this setup micro-ROS, which sets up a custom transport, sets up the allocator. That's one of the things that I've got wrong in that I've got configured wrong. Not configured wrong. I added an implementation of port realloc to the FreeRTOS kernel, which means that I have to fork the FreeRTOS kernel. Because I don't know why they didn't implement a realloc function in FreeRTOS, or they didn't officially implement a realloc function in FreeRTOS. But anyway, we did that, so we'll fix our Git configuration at a later time. Yeah. So if you remember from the last stream, we had these like idle function, get timer task memory, get passive idle task memory, and such. And that's fine. Either way, so we're starting with yes. So starting with wow. Okay. Sorry. Totally spacing out. Starting with reconnection support in micro-ROS. So let's start with just doing a Google search on that. So we got micro-ROS, and actually, because what we'll do, let's make sure we connect to our robot, stinger.local, because that should be the there we go. Okay, so export, exit, term equals x term. Oh, sorry, no. Term equals x term stinger. So we get our colors, right? All right. And then what we can do is we can do export or source ROS Jazzy setup. Okay, now we have ROS brought into context on the Raspberry Pi that's in the robot. And now let's see, how do we do micro-ROS agent, micro-ROS support reconnection, restarting agent. Alrighty, to handle micro-ROS agent, client can be programmed to detect connection loss while. So what we can do, before we actually get into this, one thing we can try is, since we have micro-ROS, what do we call it? RCLC executor spin might return if the micro-ROS agent becomes non-detectable. So let's see what happens. Let's see what happens if RCLC executor spin. really just want pub sub spin micro-ROS. Timers, executor spin. Does this ever actually... I'm curious if there's a return function. Alright, so... Micro-ROS up. Yeah, because we want to avoid that. What are they doing? No, Sagwat. Okay, hold on. No, no. Stop. Don't do that. Don't chew on the wires. Not the big ones, especially not the big ones. Those will hurt you. Okay. So, okay. Let's see. What version of ROS? So, triggered execution, initialization, add timer, while, RCL ret. Okay. We need to do execute, support init. I wonder what that is. We've never done that. It's an old version. Spin. So it runs forever without coming back. In this example, everyone to publish specially 10 times. Therefore, we're using spin sum. Okay, hold on. Okay, spin executor. I'm really trying to find like the just the API guide. Spin. Does it return? Until the ROS context becomes valid and the node shuts down, it does not return until it will continue to query, not return to control unless or the ROS context is no longer valid. Okay. Spin agent disconnect. Okay. Okie doke. So, main, let's see, ping agent, maybe there'll be a RCL publish, pinging agent again. The agent suddenly goes down when it will exit the application. This proves that your ROS ping agent functionality can be used also when a micro is already up and running, hence a transport is initialized. All right, timer callback. We don't really want to spin and ping though if we don't have to. So, executor. We don't actually want to exit the application though, particularly if Similar with one timer. I'm able to ping. Proceeds to the Finney after everything's definitely goes back to the start, attempts to ping the agent. As after as having the Finney function is that the Finney functions are this results in them failing afterwards and missing some step. As explained before, when the agent is not available, it cannot ensure that entities are being destroyed. micro-ROS middleware will return a timeout. The point source to translate this timeout to error. Yes. Oh, well, you know, so that's a good question. How do we interesting. Are you shitting me? Okay. Okay. I wonder if the transport... I bet this is going to spin until a character is available. Well, we'll see what happens anyway. Maybe we have to spin some, ping the agent, and then if it doesn't work, then... But, again, I don't want to spend a ton of time pinging the agent, right? Timers can be created and added to the executor, which will periodically execute once a timer is spinning. All right. Destroy the created entities, loop back to the first step. Okay, so I wonder what happens. So kind of one of the things we were doing before was, if we're doing RCL publish here, what happens if we try to publish to a publisher on... what happens if we try to publish to a publisher when... after we start destroying entities, right? That sounds like it'd probably be bad. Right? I imagine that would be bad. Let's see here. Interactive mode, get allocator, do support Finny. Do the thing, executor finish, timer finish. What we're doing from the timer callback. I think we were, publish message in 32. Message. I think that was, oh, sorry, yeah, that was just publishing an incrementing counter. That's all it does. So effectively, this is what we want to do to sample our FreeRTOS runtime statistics, right? So timer init default. So we would finish publisher. What does that actually do? Search Google, Finny. A node will no longer be advertising that it is publishing on this topic, assuming that it is the only publisher on this topic. All right. So thread safe, no. Allocates memory, yes. Uses atomics, no. Lock free, yes. Right, it's not thread safe. After calling, RCL publish will fail when using this. How a given node handle is still valid. Not thread safe. So what happens if we call RCLC publish on, say, the LiDAR thread, while we're tearing something down? Because RCLC publish here is, going to fail if the publisher's invalid. But what happens if we init default, init best effort? Wonder what happens. How do we initialize this to 0 essentially? Pointer to the publisher implementation. Well, publisher T. We're just using a publisher T, right? Publisher T. Yeah, so I mean, if we do that as a null pointer, it's probably fine. But again, what happens if it's done in the middle, right? Ooh. That's fun. What are you doing, kid? Alright. And so let's see here. So realistically, what that also probably means is that we need to shut down any tasks that are we probably also need to shut down any tasks that would otherwise be using this publisher. which is unfortunate, but that's fine. So let's start with that, actually. Set up micro-ROS. Set up all this stuff, right? Let's see here. Set up LiDAR, set up stuff, tilt sweep tab. I mean, that's funny, but no, down kitten. No, don't do that. Okay. So it's not thread safe, obviously, because publisher probably accesses the implementation all the time. So let's look that up anyway. RCL publish implementation, micro-ROS. Object. No. If you want to sit down up here, that's fine, but you can't nibble on things, okay? All right. I don't know. I want the micro-ROS RCLC GitHub. Okay, cool. ROS2 client library. Publisher. It's probably an implementation in here, right? Publish. Well, it's publisher init, right? Where is RCLC publish? Sample, ping pong. Where is the implementation of publish is the real question. That's what I want to know. Maybe, oh, it's RCL, not RCLC. Okay. Interesting. Okay. Service event publisher, publisher.c. Okay. Is publisher valid? Is implemented here. Is valid except publisher. Check for null. Publisher pointer is null. Implementation is null. Okay, yeah. So it does a check at the very beginning of the publish function and then keeps running. So that's why it's not thread safe. So if once we do the destroys, before we start doing the destroys, we need to we need to tear down the threads that would possibly call publish, which is unfortunate. But that's fine. So what we'll do here, I believe I already moved up all these, so main task, LiDAR task. So what we'll do is we'll add an event of some kind. So let's see, FreeRTOS flags. Task notifications, maybe. Let's see here. Often referred to as event flags. For example, an application may... Oh, wait. I don't really necessarily want to send an event, but I do want to... inter-thread flags. Well, also, we can also just use an int for this, really. thread waits for flags if flags are not cleared. No, don't do that. No, no. No. Stop being a T-Rex. All right. Thread waits for okay. FreeRTOS can block state to wait for one or more flags in the event group to become active. Does not consume any CPU time. No, no, no. Don't do that. Don't do that. Come on. You know that you're not supposed to eat wires. It's less the wires, it's more the cable ties, right? Hey. You're very cute, but you're very destructive sometimes. Okay. So realistically, I think the best thing that we could probably do is just use a very volatile variable or something. Because as long as we use something less than 32, as long as we use something like a 32-bit flag, something the same width as the processor, like it'll write atomically, more or less. It only takes one clock cycle. Hey, what are you? Hey, wiggly girl. Hey, look at this. Look at this cat. Okay, I'm gonna get that. Okay. She's also started to shed a lot. Okay. So understood. All right. So we need to have a. We could actually also just use this micro-ROS up flag that we have here. No. Okay. You get. Hey. Hey. All right. Hey. Go there. Just relax. Just relax. It's okay. Just relax. Just relax. Okay. So we've got a LiDAR RPM publisher node. We've got a firmware. What does this publisher do? Publisher. Oh, this is the publisher the timer uses. So this is the. It needs a new name. And then there's a laser scan publisher. Cat. Sit down. Okay. Unreachable agent. Exit program. Oh, and again, it'll exit the program if it tries too many attempts. Okay, well, we don't actually want that. Time at milliseconds. Wait for agent for 2 minutes. Hi. All right. So all we realistically have to kill right now is the LiDAR thread. And okay, is there a FreeRTOS? Does FreeRTOS implement a join function? FreeRTOS join. There is no direct equivalent. Okay, so there's no such thing as a. Okay, so there is no such thing as an exit, like an exit task. Or, sorry, what do you call it? A join. Okay. So I think the way we'll go about that is we'll essentially have a. What we can do is we can have a thread event, or we can use an event to essentially wake up the LiDAR task to start doing something. And then we can have a flag that says it's down. No, don't do that. Don't hit the screen. Do not hit the monitor. You have to go. You have to go down for that. No bapping. No bapping. Okay. Okay. So the very no kitten no. Okay. I'm sorry, but you guys have to be outside this room now. I can't trust you. I'm sorry. Okay. Okie doke. Sorry about that. They're being not the best right now. They're getting to that age where they're testing boundaries, right? But basically a teenage cat. Best thing I can do, like, you can't really put them in timeout. They don't understand. Like, you can't punish them. They don't understand. Like, and who would want to punish a cat anyway? Realistically, the only thing I can do is either redirect their attention, or I just have to put them outside of where I am, in the room that I need isolation in. Anyway, so what we'll do, yeah, I wonder if, yeah, sorry. So what we'll do, we're just going to, yeah, so we have our LiDAR buffer. We've got a bunch of code kind of hard-coded in here that we don't necessarily want to do moving forward. But for now, we do need a way to essentially signify that the LiDAR thread has responded to being shut down. Which how I think we'll go about that is we'll use a binary semaphore. So basically, when the LiDAR task starts to operate, it sees that micro-ROS is up. It'll take the semaphore, and then just keep going, and then it will release the semaphore when it stops working, or after it detects that micro-ROS goes down, it'll release the semaphore, and then wait for the flag to go true again. But then what we'll have in order to wait for the thing to shut down, we will basically have the main thread take the semaphore as well to make sure that the thread has exited. So how we're going to do that is essentially RTOS semaphores, and we can do FreeRTOS binary semaphores. Task notifications can provide a lightweight version. Notify a task that the transmission is complete. So give would say wake the task up. Array index. I don't know what array unlocking is. Then 45% faster and uses less RAM, although this isn't a performance thing. So that we don't really have to worry about this too much. Yeah, and thing is, we'd have to notify main task and also, yeah, so realistically, we need to, might as well just use a semaphore. I think I just want to use a semaphore. It's just easier to think about right now. X binary semaphore. Yes, so we'll do a semaphore handle T, IMU, or LiDAR task semaphore equals null pointer And then we're also going to do this micro-ROS up. We're just going to bring this up further up. Say RTOS flags, publishers up. Or I should say, stop publishers is false. We'll just say micro-ROS publishers, and we're going to get rid of this int32 message thing because we don't need that. We're going to say statistics publisher. We really don't need the LiDAR RPM, or I mean, we might like the LiDAR RPM publisher. That's fine. We can keep that. And so this will be our statistics publisher. Laser scan, firmware, firmware statistics. And we'll call this laser RPM. Although we don't really need the laser RPM. We really don't. Node, we'll call this firmware. Namespace. Yeah, we don't have a namespace right now that we want to deal with. And this will be the, well, comment this out for now. Basically what this is going to be is micro-ROS timers. Okay. So, and how we'll deal with this is, I don't know if we actually need to tear down support again. Yeah, because it takes argc, argv. Yeah, we don't actually have to tear down support per se. But what we will do is, we're going to have to do a 0 allocation of all of these. Is there an RCL get default? No. We'll just say null putter for all of these. Executor. Oh, we need to be able to, I just want to 0 initialize all of these, right? This is main CPP. Use type T. How do I, hold on, C++, C struct, 0 initialize C struct. I think it's equal to, all members are 0 initialized. God, this, I can't remember, right? Okay. Hold on, trying to remember. Does my struct zero initialize? Pretty sure it does. Oh yeah, 0 initialize. Okay, that's what I thought, but I couldn't quite recall, right? Okay. So the reason we want to 0 initialize is basically we want to make sure all the pointers are 0, you know, so that we can tell that things are invalid. And we're going to do the same thing up here, just 0 initialize stuff. And then down in here, we want to do set up semaphores. We'll do X semaphore create. That's actually going to be LiDAR task semaphores X semaphore create binary. Okay. I believe, right? Q generic create. Oh, interesting. Oh, does it really use a Q? Okay, funny. That's fine. Some for create binary. Perfect. Whatever. So the way that we'll do this is we're not publishing anything from here yet. Micro-ROS up. So yeah, so publisher init default, statistics, node init default. Yeah, so we need to support do we have to tear down support as well? Node Fini. I don't think we need to tear down support, right? RCL node, RCL publisher, RCL timer, RCL C executor. Support. Go to definition. Probably need node. Probably need to W micro-ROS ping agent. Cannot be called concurrently. Timeout. Attempts. I wonder if it can actually detect the agent going down, and how does support talk to the agent as well? Create some support data structures. Hopefully we only need to do the node level of things. So we'll actually move this part to here. We'll see if that works. Again, we've done some things. Deprecated, use default 2. That's fine. We'll figure that out. So micro-ROS up. Rather than doing micro-ROS up for now, what we'll do is we'll just do X semaphore give, and that's going to be the LiDAR task semaphore. All right. Wake the IMU thread. Sorry, wake the LiDAR task, and we'll have that spin the LiDAR. And so what we'll do here is in the LiDAR thread, we're going to assume that we can always publish now, essentially, and we're going to not publish RPM because we're not doing that anymore. We're just publishing scan. Why is that an error? Or ignoring return value, that's fine. Okay, and then in here, what we'll do, we're going to set point. We're going to turn off the LiDAR motor, and then we're going to wait for micro-ROS to start. Let's say X semaphore take. This is going to be LiDAR task semaphore, and it's going to be PD, or port max delay, right? Yeah. All right. And then define, it might return, yeah, if not equal PD true, terrible, a serious errors happen. Or actually, we'll just say while not equals PD true. Okay, port max delay. Perfect. Wait for the micro-ROS agent to start. Okay, cool. Nothing to do here. It's fine. We're not doing the micro-ROS up thing anymore. We want to wait for... Honestly, let's just give ourselves 10 minutes. That's fine. Okay, compile. Then what we'll do is we'll do our deployment, Flash project with SWD. Oh, we have to remember to wake the LiDAR back up. So we spin down the LiDAR. Right, we spun down the LiDAR. We need to spin up the LiDAR. 0.2. Perfect. Already compile. SWD. Perfect. And now the LiDAR won't spin up until the agent starts, which we can do with ROS2 run stiff. Oh, source. Sorry. ROS2 workspace source or not. We might have to. It might have been the micro-ROS workspace. Directory to micro. Yeah. Okay. Cool. So now it's source, local setup, and ROS2 run. The LiDAR spins. But we don't see a connection, which is bad. We might actually have to wait for... Well, actually, I mean... The curiosity here is that we did get through the setup of things because we did a semaphore give, but we didn't see the nodes come up. So we might actually need to do the agent before the support, which is a little silly, but you know, whatever. Flash project SWD. There we go. And stuff came up. And the LiDAR spun up. Oh, LiDAR is not doing things. Oh, that didn't work. Oh no. What happened? What happened? So what we'll do... Okay, we gotta read position, write position. We overflowed the... probably terribly overflowed the LiDAR DMA buffer. Maybe we think about how we do this. So that's really not working very well. That's set point, set speed. We'll compile that, flash that. Ooh, that's bad. Oops. That's very wrong. The LiDAR is spinning very, very fast. Very, very fast. What happens if we... Yeah, very, very fast. Okay, that's not good. Ugh. Okay, clearly that didn't go correctly. What if we just disable publishing for now? Nothing to do here, while not true. Compile. SWD. And then that seemed fine. That seemed fine and happy. We got our publisher, but our shell publish did not work correctly. Interesting. Very interesting. If we kill this, come back, yeah, obviously it's dead. But so at least let's test now to see if we can shut this whole thing down. So we're gonna do, let's do this. Going to while true. Going to synchronize with the micro-ROS agent. We'll do a const expressor const int. Timeout ms is 1000. Const expressor const uint 8. Attempt equal 10. If rmw ros ping agent. Timeout ms attempts not equal rcl ret okay. Then we'll just continue. Start setting up. All right. So do that. Add timer. It's up. Wake the LiDAR task. We'll do this. Spin sum. Execute RCL writ. Invalid argument is any parameters null pointer. Timeout if return timeout no data available or error. Parameter. Okay. Error if an error. Okay, so if we'll say if, well, actually we could say while true, if not equal, equals ret RCL ret error, then break. Tear stop micro-ROS executor. And then we have to do we do mic RCL publisher, oh actually stop the LiDAR. We do stop publishers equals true, x while x semaphore take LiDAR tasks semaphore not equals PD true. Do nothing to do. All right. Sorry. Port max delay. Okay. Stop the executor. Publisher fini. Publisher. LiDAR. Scan publisher node. Do RCL. Timer fini. Just the timer. This is going to be statistics timer. Going to be statistics timer. Fini RCL C publisher. Just do it all backwards, right? Statistics publisher node RCL node. Oh, executor fini. Executor CL node fini node RCL support fini. All right, cool. And we're going to delete this initial version of this. Default allocator. Oh, did I break setting up the allocator? No, I didn't. Okay, cool. Okay, no, we're good, because the allocator was actually configured down here. Perfect. Okay, so it's not happy with, it's very not happy with me because I deleted the that. Okay, so that might stop semaphore take. So we're going to come down here and say while start up the LiDAR. Actually, the question is whether, honestly, what we can just do here is while this is going to be while true. to wait for micro-ROS to start. Start up the LiDAR PID. Set point 300.f LiDAR PID dot. I actually don't know if I gave myself a way to reset the internal counters. Oh, positional PID. Set point. We've got the build-up essentially. Actually, let's be honest. Let's just reconfigure every loop. We'll reconfigure the PID thingy. Why not? LiDAR speed while not stop publishers. Give up some for XM4 give task delay EDMS to ticks 1000 give realistically needing to do this delay is just evil, but that's fine. We'll just do it for now. We'll basically just make it wait 1 second after dying before it can be restarted, which will give us plenty of time to wake up or to capture on the other side. Where's this index? Index is 0. Perfect. Semaphore. Okay, compile. We're going to flash it. Was okay. We'll run the agent. The LiDAR spun up. Kill the agent. Although we're not actually really doing anything, so the agent it's not actually detecting that something went wrong, which is kind of funny. At least I don't think it is. Oh, well, we should also probably stop publishers equals false. And actually, what we want to do is we want to bring in messages string. Because this will be a string. RCL std messages string. Stats that we'll do std messages string knit stats data. Well, we can't publish an immutable one, so that's fine. Okay, so compile. Maybe that will cause a failure that'll wake the executor up. Oh, that's bad. That didn't work. Oh, that really didn't work. Why did that really not work? Oh, I know why. Oh. That's not, still not working. Ew, it's blowing up. Or it's, well, the LiDAR's spinning up to ridiculously high speeds. And we don't know why. Okay. Why will not stop publishers? I am here now. You can begin entertaining now. Okay. Well then. So, where are we? So basically what we're trying to do is, since we did all this effort to migrate over to FreeRTOS, we want to have, oh, well, actually, sorry, before we even get to that, we're doing right now is, if you remember from the previous streams that we were doing on this, whenever we would disconnect the ROS agent, or the micro-ROS agent, we actually had to restart the microcontroller to establish a new connection. But what I really would like to do is not do that, and just detect that start your micro. Just detect that it's down and then restart the agent on the microcontroller. Or sorry, restart the microcontroller's micro-ROS code when it detects the agent has gone away. Currently having a little bit of trouble with that. When I start it, the LiDAR goes absolutely insane, and I don't know why yet. I feel like it's odd. And one thought too would just be to have the LiDAR do whatever it's supposed to do, and I mean, we could just, rather than doing this PID thing, we could just set the light. Also, we just decided not to. But anyway, I don't know why it's like this. This is not doing what it's supposed to be doing or something. So, LiDAR synchronize. LiDAR packet loop. Because we're not even using the publish method. We're just calling, we're just sitting here in a loop, like running, hopefully processing the LiDAR. So we might have to reconfigure the DMA on the LiDAR. Claim unused channel. Set exclusive channel. Handler. Okay. Could just set, because on right position next is the right position plus the LiDAR packet. Yeah, we could just reset the buffers. And that might just work. You know what? Let's try anyway. That might be what's doing us dirty here. LiDAR read pos equals 0. LiDAR write pos equals 0. So yeah, like if channel A throws an interrupt after this, it'll... Yeah, I mean, this is the same handler, realistically, other than just setting the different write address. So yeah, this should work. Theoretically, this should work. In theory. All right, so if we... Yeah, we'll zero out the buffer, wait for everything to do whatever. So yeah, flash, SWD. All right, and if it were to be spinning, we reconnect. Seems to be fine. Looks like what ended up happening was just the bad data and the LiDAR buffer overrunning. Looks like kind of what it was, which is really weird. Oh, nope, that didn't work. Now it's going to the moon again. Okay. Well, we actually wouldn't have found out because we need to stop the LiDAR motor. Okay, so spun down, start the agent. LiDAR begins to spin. Kill the agent. And it's still spinning. Presumably because it's not actually aired out yet. So we're gonna have to say, like, if we detect a failure on publish, I guess we could throw a stop, or it will throw an error, I guess. I don't know. Always be running the LiDAR and only forward it. That I mean, yeah. So that's what I was doing before. Noise the LiDAR makes sounds like a film reel, so consider it a feature instead of a bug. Cinematic mode. Okay, yeah. No, so that's definitely an option. It was more of just like, on one hand, it was like, oh, don't waste energy spinning the LiDAR if the robot's not actually running software. But it probably sounds like a film reel because the thing's belt driven, right? It's there's the LiDAR sensor thing, and there's a motor off to the side with a little rubber band that goes around it to drive the LiDAR. Let's see here. So I need to figure out how to, I need to detect, spin some. Maybe if we just use executor spin and no timeout and see if something happens. Yeah. Right. Well, I mean, we can just do this, I guess. It shouldn't return unless there's an error. Hypothetically. Spins up. Kill the agent. Still running. Still seems happy. That's weird. We're not weird, but... it's annoying. Oh, did I do this twice? Yes, I did. I did this twice. Why did I do this twice? Okay. Interesting. Let's see if there's a way I'm supposed to do this. Micro-ROS, detect, agent, disconnect. Agent ping, implement the mechanism on the periodic ping to check its reachability. This is done using ping variant. If the ping fails, indicates a disconnection. Operate as usual, spinning the executor, publishing messages, failure detection. Continuously monitor for communication failures during the micro-ROS API stage. Involve checking return codes from SpinSum or other destroy entities. Ping variant, yeah. Support, SpinSum. If it's not equal OK and not equal timeout. Okay, well, let's see. Auto RC equals RMW. No, that's not it. All right, we'll delete the duplicate agent connect thing. Break. So we'll do int RC, or auto RC equals SpinSum if RC not equals ret OK and RC not equals CL ret timeout. Timeout being there was just nothing to do in this window. My Flash project. Okay. So we start trying to do that. If we kill it, well, nothing happened. Right, we're not running the debugger. Okay. So, well, that sucked. Okay. Maybe somebody's got a thing. Yeah, I already did that. Powered it off, cleared the buffer, restarted it, still freaks out. So there's probably some other bug in my speed control of it somewhere, but figure it out eventually. Looks like we are, as I've also been trying to avoid doing this ping function because it takes a, I don't know how long it takes. You know, it's a serial connect. I mean, it's USB, but you know, it blocks the whole thing doing this ping. So you know, it's not something I'm particularly thrilled about calling frequently. So, I mean, at the end of the day, though, I guess we try. Or not try, we do. You know, if... Alright, fine. Break. And we'll just change this to 1,000. If... Ping, timeout, we'll give ourselves a 10 millisecond timeout. One attempt, not as okay, then break, because something went wrong. Okay, attempt to ping. Attempt to ping the micro-ROS agent. Okay. Compile. Flush. Alright. Spin up. Thing spun up. Kill it. And it powered down. Look at that. Didn't come back up, though. Oh, there it goes. Powered down pretty quick. Restart it. Wait for the agent to come back up. And it came back up. Okay. Cool, and the lighter's not going absolutely bonkers. I did, yeah, I did try the... How long did I... wonder how long I waited there for it to go down. I wonder, I'm kind of curious what the cost of doing this ping is. We'll have to add some like profiling or something. Just seems a little it seems a little annoying to have to do this. I don't know how long this takes. But otherwise, whatever. So we'll come in here. We'll start publishing our laser scan again. Compile flash. Came up, perfect. Let's start Docker. Go to projects, bot, Docker run. Hold on. Where was I just asking it to run? I just want RViz. What? Oh dear, I might have accidentally nuked my history. That would suck. Okay, well anyway, Docker run ROS2 workspace, ROS2 workspace. Whatever. Oh, we have to do that xhost thing. Xhost plus. Let me do ROS, we do RViz2. And then we do add laser scan, go. Zero messages. Yay, it's not working. Well, that sucks. Clearly I broke something. Discard. So we'll do a ROS2 topic echo topic list. Yeah. Before we get too let down, or let's look at what happens. Maybe again, it's just networking shenanigans. Nope, it's not publishing. That's unfortunate. Okay. Publish, LiDAR scan publisher. Well, how about we just make sure that this is the first run of the agent after powering this up, right? Not do any. Okay, cool. Still not publishing. That's not good. Oh, wait, that's on okay, it really isn't working. Okay, so what have I done besides everything? Let's see here. Publish message when scan is complete. Start do map. Do the thing. Get everything. You know, I don't actually know if this loop is running. Might be stuck inside of RCL publish for all I know. So yeah, we'll actually switch to debugging here. Debug project. Cortex debug. Oh, good lord. Go debug. What's wrong with it? With external OpenOCD. Server path. Of course it's not going to work. It's freaking SVD file. GDB path. Server path. Of course it's not going to work. What the hell? That's the container. That's the robot. That's the other. Oh, I need a new one. LS, Pico SDK, OpenOCD. Oh, they actually added a symlink to exe. That's funny. Main. Fine. Multi-arc. Failed. Function. Expecting. Could not start. Does the program exist in the file system? Right. That bug from a long time ago still doesn't seem to be fixed. Launch. GDB path doesn't seem to work. So how about we find GDB and we'll do find dot dash name GDB Pico SDK. Because it's going to be called ARM none GDB. Because of course. 14.2 rel 1. Oh, Raspberry Pi. There we go. Now the debugger runs. Oh, dearie me. Okay. Oh, you know, maybe the reason the LiDAR went to the... it looks like the reason the LiDAR may have gone to the moon initially is because if you don't set the LiDAR RPM, it defaults to 100%. That's perfect. Okay. Because it went to the moon the moment I started the debugger, but the moment I continued past main, it was seemingly fine. So what we'll do is we'll drop a breakpoint on... RCL publish. Actually, what we'll do is we'll drop it on index. And then we'll do a agent start. Went to the moon. Received SIGINT, studio connected. Went there. Just to make sure we don't break the LiDAR, we'll just do this. Okay. But we never escape RCL publish. Okay. If we got rid of this run to main thing and let it just keep working, not break on start. Ah. Publishes a couple of times and then dies. Okay. Neat. Okay. Interesting. Interesting. So it was working before, but now it is no longer. And it's getting stuck in RCL publish. But the thing can't start up until we give it the semaphore. And it's given the semaphore here. Reset everything, spin it up. While not stopping publishers. Let's see if we fail out or something. No, at least we're not failing out, but we might be we are getting stuck, I guess. I don't know. Interesting. Okay. If we comment that out. Oh, it's entirely, well, the only thing updating index is that thing where it would be stuck in. So if it's stuck there, this thread can't continue. Which would, explain why it's not publishing anything, but, because if we drop a breakpoint there, it never actually, doesn't actually look like it gets there particularly often. It's off, we start this. Thing comes up, never publishes. It never gets past it. It's really, really weird. As we initialize this, initialize all the default stuff, laser scan, sensor messages. Oh, that might be something. String. Publishing string. The fact that we were sending string. Anyway. Messages, laser scan. Published one message. And we could just do something a little silly. And we could do if index equals 0, it's going to fuck up the laser scan. That's all that means. It basically it's the counter on the packets coming in from the LiDAR. GPIO NER LED Pico default LED pin. GPIO set. Which function is just GPIO. It's just 0. Huh. If I just don't set function, it's automatically a GPIO pin. That's probably the case. GPIO set out. How do I... Forgetting how to actually set a pin to a certain state. Wow. Okay, I know I did it in the motors thing. Put. Okay. Put. And what we'll do is just silly, but if we see things blinking, we see things blinking. Even though we have a debugger, having trouble making it work, so we'll just blink an LED. Let's see what the LED looks like. It's not on. Does it ever turn on? Like, off. If we set true, will the LED come on? No, the LED did not come on. I must not be using the right pin. Oh. Missed one. Okay. Missed one. There we go. Turned on. Okay, cool. Turn that off. And then come back here and turn this shit back on. Yep, it stays on, which means it's stuck in RCL publish. There's nothing to do with the laser. It's just stuck in RCL publish forever for whatever reason. Laser scan message. So if we say pause, maybe we can see where it's stuck. Well, it's stuck in idle task. Check tasks with termination. You know, I wonder, what happens, because now that we're doing this disconnect thingy, we're doing this ping, what happens if I try to call publish from a thread whilst the ping is happening, or I try to call publish while we're not inside of the executor loop? What happens if I, you know, comment this out? Just out of pure curiosity here. Okay. Still stuck on from what it looks like. I'm sorry. Echo laser scan. Yeah, it's still not publishing. Okay, what the hell? Okay. Okay, well, at least let's try publishing something. So we'll try publishing something from this timer here. So we'll say static char statistics buffer 1024 equals 0. And what we can do here is message.data equal, or message.data.capacity equals size of statistics buffer. Message.data.data equals statistics buffer. Message.data.size equals and copy. This is going to go into statistics buffer. Statistics buffer. Hello. What? Oh, something went wrong. Oh. Okie doke. Perfect. Then we'll just publish that. Okay. Not getting anything. All right. Something is very wrong. What if we never try to publish light? Or well, let's try to never publish the laser. See if the firmware statistics ever works. Oh, there it goes. Something about my usage of the laser scan is very busted. Is it because I increased the freaking timeout? It's the only thing I can remember changing, realistically. What's the number of handles? Do we need more handles? Is that what was wrong? Well, let's enable some of the code again. Although we're breaking the rule about only changing one thing. It's gone again. Alright, interesting. What if we did something crazy? Or, you know what, let's try something a little silly. Or not silly, but, let's try pinning the LiDAR thread to the same core as the micro-ROS executor, seeing if that's what's up. Also, with what we're doing here, we might need more stack for all I know. Which I don't. Either way, let's try this first. See what happens. really funny if I blew out the stack, because this is a lot of data potentially. Oh yeah, look, one go and it hung. What if I blew out the stack? That'd be really funny. Let's try doubling 16, 384. No, that didn't work either. Okay. Well, why was it working before, but it's not working now? Obviously, we changed a lot of things. Well, not that many things. But what we will do is reduce the spin time, because this was 100 milliseconds before, and then now I increased it to 1 second. So let's see what happens if I reduce this again. Still dead. No, that's probably good. Okay. What if we get rid of this ping? Still only one. Okay. What if we got rid of the timer? Just publish the laser scan. Agent. Oh, hey, look, a laser scan. Okay. Interesting. Very interesting. Wet. Oh, yeah, now it's dead. Okay. I don't like the fact that it said resume. Okay, hold on. Yeah, and it dies. Yeah. Interesting. But if we don't do the ping... Macro laser scan. There are the laser scans. Huh. It's also completely and utterly fucked because it's not supposed to be spinning like that. That means that the pointers into something are broken. Lovely. Alright, something is clearly very broken. I've clearly very broken something, and I really wish I had committed code. Okay. Well then. I think it's still broken. Yeah, it's still busted. Oh dear. Okay. Alright. I've very clearly broken something. So that has something to do with the LiDAR speed not being set up correctly. so. Oh. It was due to the LiDAR RPM not being managed correctly. Interesting. Very interesting. All right, so that's actually working again. Okay. Fun. Fun. And now what if we do... What if we were to spin for a second? Instead of... It's very broken. Okay. Broken. All right, yeah, busted. Okay. If we try to do a ping every 100 milliseconds, it breaks. All right, that's not good. What if we pinned it to the other core? Well, that's fine. That seems to be working, you know. Well, we also commented out the ping, didn't we? I did. Put the ping back. Well, shoot. Okay. Publish from the other thread just fine, but if this whole ping agent thing, agent publisher to hang. So I'll spin some, spin heavy. Okay. I wonder if there's a better way of grabbing an error from publish. Like, maybe... Okay, we do break. I don't know. We put a breakpoint there. Cool. It seems to be doing something reasonable. What happens if we kill the agent? And it dies. Okay. And it dies. Okay. What does RC equal? Okay, that might be what we need. That might actually be what we need then. If publish will return an error if the agent dies, then we can propagate that error out, but we're going to need a way to notify. Well, right now because it spins some, we can notify that way. But actually, you know, another interesting thing too. Let's get rid of our break here. Or well, we'll keep this. We'll keep this. But we'll leave our we'll know it died if we get there. But what we'll do is let's increase this back to 1,000 because since we pinned it to the other core, we shouldn't block, right? Yeah. Let's see what happens now. Let me get the laser scan just fine. Okay. And the thing is if we pinned it to core 1, we're doing it as idle priority. I believe we're setting this priority higher than the main thread. We're just really waiting on something from an interrupt to wake us up. Basically DMA stuff. Will kick task notify. Yeah. But I believe that was causing errors before, right? Well, now it seems to be fine. What the hell? I mean, whatever. I have no idea sometimes, you know? Laser scan. Topic, laser scan. See if we can get 5 hertz. Nice. Discard. Alright, well, that was working fine, clearly. Because even though this is spinning... yeah, so how do we... If we can kick the executor out by using those guard conditions, right? Or... micro-ROS cause executor to exit. To exit. Prematurely. Which becomes invalid if the communication link fails or the agent shuts down. service callback, memory allocation issues, concurrency problems. Well, we're fine with publish returning a failure. I mean, we are. I mean, we want to break if that happens. We'll put that there. But we also really want to see this exit is the thing. If the agent goes down. Interesting. Why the pulsing? We never got the breakpoint though, which means the executor never exited. It only... Okay, that's funny. All right. You know, I wonder if my TDDIO transport put string. Interesting. RCLC executor spin does not exit when agent disconnects. Function itself doesn't exist in ROS2 client. Causing, I'm just gonna get not exiting, does not exit, sorry. Is agent alive? Oh. Okay, well, maybe... Okay. Okay, interesting. Okay, so looks like we have to manually, well, I mean, Google AI results are crap. But anyway, maybe what we do is we would say that bool error detected. Agent error detected equals false. Okay. Then what we're going to do is in here, we're going to say Publish. If it's not okay, we're going to break. We're going to say error detected equals true. And then fail out. Publishers and not error detected. And we're going to say this is actually going to be or equals true. Equals, I'll just equals true. It's fine. And that spins down. Okay, big compile. We'll loop for 100 nanoseconds at a time. It's way up at the top. Okay, compile, debug. Look at laser scan. We see laser scan data. Let's check RViz. See if laser scan does anything interesting. It's funny that it always comes up at an odd rotation too. Maybe that's fine. Who knows? Weird. Okay, anyway. That's me. That's the wall. Okay. 5.1 hertz. Okay. So RViz is working. That was working. Okay. So, we've got, actually, RViz. Bring that back. Bring back RViz. Add laser scan. Topic laser scan. 144. All right. And that's not going to help this. I mean, it's only operating at 5.1 hertz, right? Yeah. And so we're going to kill the agent. And hopefully see the LiDAR spin down. Which it does. The LiDAR spun down. If we reattach, hopefully we'll, well, nothing happened. Nothing. Okay, well, it's not trying to publish. That's good. Oh, right. It hits a breakpoint. Or it's supposed to have hit a breakpoint. Pause. Executor prepare. Interesting. Run. Laser scan comes up. It's doing its thing. Kill the agent. Powers itself down. Come over here. We forgot to exit on, oopsie. We forgot to, while not error detected. Okay. Laser scans back. Kill the agent. We see everything spin down. Bring it back up. Laser scans are back. Kill it. LiDAR spins down. Bring the agent back up. The LiDAR spins back up. And we have a laser scan again. Alrighty. We implemented reconnect very shoddily. Okay. Well, that's cool. I like it. And let's restart this here. Yeah, that. The right hurts, right? Yeah. Okay, cool, cool. Perfect. Do that again. Stop. Start. Very much did not work. The LiDAR died. That worked. Interesting. What happens if we try to spin the LiDAR a little fast? Like 360. Somebody told me I might be able to get 6 hertz out of this. So what if we... 360. What about... Let's go for Brooke. 7 hertz. 420. We'll try 7 hertz. So 1 divided by 7 point F. All right, time between. Okay. Oh, a complete failure. Complete and utter failure. Well, that doesn't help me. I'm spinning it too fast. 360. That's 5, 6 versus 6 times 6, which is times 60. Okay, yeah. Well, that's not right. There we go. Now it's working again. It's not designed to go that fast. It's 5 hertz. It is. I was just curious. At any rate, I was just curious. Okay, now we're working again. All right. So let's reduce the thread size or the stack size back to what it was. And then we will do we'll put back the timer and timer, the timer fini, that publisher. If ret not, we can say auto. If not equal RCL ret okay. We say error detected equals true. Error detected equals true. I'm also now kind of curious to see if the little thing blinks on the bottom. I can't see it blink. It's blinking too fast. So we'll take off the blinker. Publish laser scan. Publish laser scan. Not equals error detected true. Not equals error detected true. It's probably just initializes everything to 0. Yeah. Okay. But hey, this was borking everything. All right. So now we can back to 2.0. I mean, we can try. Shut down LiDAR. Okay, cool. Just to keep things all near each other, you know. Okay. Compile. Flash. Oh. Interesting. Well, I added the freaking timer publisher back and it stopped working. Great. Echo. laser scan. The mere fact that I have a timer is causing problems? Maybe it's this restart thing. Hold on. Yeah, maybe it was this, just this restart thing here. Okay. Oh, well, we were running the time, or we weren't running the timer. It's almost like the fact that I have the timer at all is causing me problems. So if I comment out the timer, or comment out adding the timer anyway. No, sorry. Comment out the timer. Let me deploy. Yeah, and there's a laser scan. What the heck? What the heck? What is going on? Okay. Interesting. Not even doing anything from the timer. I just did I not do the timer correctly? I did increase my heap size, right? FreeRTOS config. Yeah, to 256K. Huh. Such strangeness. Maybe it's what I'm doing inside the timer that's causing me grief. What is the timer callback? It's a void function, doesn't return anything. Callback, auto start, which is true. Okay. Okay. It's doing nothing. Okay. Weird. Just the mere act of adding this timer is causing problems. And I don't know why. Huh. Just to check what we're doing, if I start the debugger again, we get in this state. Huh. Okay. Let's just see if we have to do anything. Eh. Hold on. Interesting. Callback. Last call time. Use timer, publish, wise, ping timer callback. Two. Default. And publisher timer init default. Executor, num handles, executor init. Okay. We shouldn't have to. True. Pong timer callback. Okay. I don't think that'll help. Nope, dies immediately. The heck? little frustrating, not gonna lie. Not doing anything. And it gets stuck. Huh. It's basically stuck. What is happening? Interesting. Very interesting. Wonder what I'm doing wrong. I really wonder what I'm doing wrong here. Like... This was indeed working before. What if I make sure to put this on another thread again, or another core? That's a little silly, but, you know. Nope, it's completely not working. Completely not working. Put a only send the message if the LiDAR's spinning fast enough. How about that? I think it's still stuck, though. Yeah, it's still stuck. It's just the LiDAR came up to speed before it got into its being stuck area, right? Why does adding a timer break things? I don't understand. And now it's, working. Okay, well. Interesting. Who knows? Who knows? Back, you fix it yet? Sort of. I found out that adding the timer is what's causing things to hang. Which doesn't make a lot of sense to me because before I was using a timer and it wasn't causing hangs. But I don't know. So I don't know what I changed. Or, well, I changed a few things. But firmware node init. Agent. Anywho, all right. Let's do this file, new text file. Oops. Rather than doing any of this, what if we... How long is my frickin' history on this VS Code? So I forgot to commit the code like a dumbass. Do. All right. This is where we were this morning. This is where we were earlier, right? Yeah. All right. With no reconnect support, so we'll start that crap. All that's created. Actually, we ought to restart the freaking agent here. She now isn't working either. Now that's not working either. What the heck? There we go. Just my drink. All right. Yeah, that all was working. Publisher init default. Publisher init default. Init add timer. One handle. fact that I was publishing that before. Because I was publishing a that first, or why? Okay. I comment out the RPM publisher. I start the agent. That doesn't work anymore. But if I publish a small message first, and it works. What the hell? You know, I'm really starting to not like micro-ROS. Really. I literally, by sending a small message before the laser scan, and now it was able to publish. If we comment this small publish out, then the timer... What even? Huh. Weird. That's ridiculous. Okay. I really got to dig into this at some point and figure out what the heck is happening, because I don't know. I don't understand why this is hanging everywhere. Or if sending a small message before a big message makes timers work. Like, here, let's because we did this. Let's copy this back. What if we did the same thing? I'll delete that thread affinity thing. What if we did the same darn thing? And brought back the statistics publisher, or not a statistics publisher, but brought back a something or something, just something. So we'll put the counter in here, or we'll bring back LiDAR RPM. Why not? RCL publisher, LiDAR RPM publisher. Laser RPM. This is going to be int. All right. All right. That, hello world, plus plus. I come down here and publish laser RPM. Actually, we could use a float instead of a... What if we did a float? Float 32. All right. We did that instead of float 32. We do a... Publisher, RPM message, null. It's true, break. Okay. Did that. Then we're gonna do, make sure to do Finny on all right. Fine. Compile. Flash. Well, ROS2 topic list. Excuse me. Laser RPM at least. ROS2 topic echo. Laser RPM. That's coming out. Firmware. Statistics. Did I actually publish? Oh, I forgot to add the timer. That would do it. Oh yeah, and look, now it's publishing. Timers are working. I added... Oh, dang. Sorry to hear that, Danish. Alright. But yeah, literally just adding a small message publish before the other... But literally, if we comment out that small message publish, this whole thing hangs. Which means there's some horrid race condition somewhere. Something, somewhere. Now what happens if we do pin this to another thread again? Like, LiDAR, task handle, pin to the second core. No, it's coming out too. Although the LiDAR didn't spin back up. That's funny. Hey. That's not good. Flash project. If we pin it to core 1. That's happening. And now lasers are publishing again. Look at that. Yeah, exactly. Concurrency issue somewhere. But where? Like, that's the question. Is clearly it's a concurrency issue. It's just not... It's just somewhere. Like, supposedly we're building the FreeRTOS version of this that uses... I have a disdain for it. Yeah, I sent that to you earlier. Yeah. Yeah. Oh, I know. I said that, and I do agree. But the thing is... But where... Where is the concurrency issue? I know it's running on multiple threads. Supposedly we built the thread-safe version of this. But yet, there's something happening somewhere. And, the main trouble I have with this too is like the build system for this this micro-ROS thing, it literally just compiles the entire thing as this random shared library, static library, and I don't have the debugging symbols, which is really sad. It'd be really nice if the build system could, just spit out all the files I needed to compile. But anyway. So see, look at this. If we comment out this publish of the smaller message, reflash the project. Yep, it's gone. It's not working. But yet, we bring this back. And there it goes. It's working again. What if there's like a flush function I need to call or something? Anyway, I'm gonna stew on this for a little bit. So I think I'm gonna call the stream here tonight. It is getting kind of late. So yeah, we'll leave it here. I wish I got a little farther, not gonna lie. I wanted to get to moving things around today, but it's just, I spent a lot more time on that. I didn't even get to printing out this. You know what? Actually, sorry, I'm not gonna call the stream. Let's at least try to do that reporting FreeRTOS statistics before we get off for the evening. All right, runtime stats. No, don't open Claude. All right. Macros are required. These can be defined in FreeRTOS config. Configure timer for runtime stats. Get runtime stats. Chair, PC write buffer. See the runtime stats page for the full description. It was just here. Port get runtime counter value. The counter should be at least 10 times the state. Okay, well, let's make sure we do this right. Okay. FreeRTOS can optionally collect information about the amount of processing time each used by each task. The vtask get runtime stats API function can then be used to present this information in a tabular format as shown on the right. Absolute time, time percentage. Configure timer. Configure timer, generate runtime stats. So we're going to open up FreeRTOS config. Look for run, generate runtime stats. We're going to enable that. We're going to compile. It's probably going to complain about certain things being not ready. Yup, it died. If config generate runtime stats, then configure timer from must also be defined. Okay, cool. I'm going to define configure port configure timer for run time stats. Should call a port layer function to set up a peripheral timer counter that then can be used. All right. Just going to define it as empty. Oh dear. Just fine for now. Which is fine. We're going to figure out. Port get runtime counter value or port alt. Okay. We need to define. Where the heck did I end up? Get run time Counter value is implemented as basically time get you at microsecond 64. I think there's one more to define, like ticks per the resolution, essentially. Of course. Where does that come from? Pico transport. Comes from hardware timer, timer.h. Expected before study. Oh. Okay. So declaration pico std lib. Maybe std int pico std lib. Yeah. Okay. Compile. Yeah, okay. Something buggered. Alright, so we'll just have to define our own. Let's say extern uint 64 time okay. Busy wait. Freaking kidding me. Oh, Okay, finally. We're good. Or, well, that was fine. Anyway. Problem 17. Terminal. Oh, it fully compiled. That's not quite what I expected to happen. Examples are provided. Maybe it doesn't actually really matter what the time base is. It just does it. Once this has been set. Okay, well, I don't actually know if it matters. So whatever. So what we're gonna do is, now that we have this, v get runtime statistics, char PC write buffer. No system state. V task get runtime statistics. 40 bytes per task should be sufficient, which is fine because that's true. That's what we got. But stats for full description of this feature. I definitely like the version that has a buffer length. So what we'll do, message init, void buffer length. Yeah, anyway, I guess, we don't actually know how long it's going to be. So what we're going to have to do is we're going to v task get runtime statistics. Message dot data dot data dot data dot capacity. Oh, geez. We're gonna do, yeah, v task get runtime. Oh, stats. It's the only thing we got. Message.data.data. Compile. Oh, is it really not? What? V task get runtime stats. Oh, come on. Define. Oh, get runtime statistics is not defined. Use stats formatting. Use trace facility. Okay. Use stats formatting functions. 1. Okay. Data message. Statistics, message.data.data, message.data.capacity, message.data.size equals strlen.data.data. So like a strlen. Yeah. All right. Cool. Perfect. Maybe that'll tell us our CPU usage of things. Or we break it even more. All right, flash. Hey, look at that. Stuff is happening. Although the formatting is really bad. Line 246. Well, before I started moving stuff around. This one you were talking about? Anyway, okay, so gotta figure out how to display this. Idle less than 1%. Oh no. Idle 1. Less than 1%. Okay. Maybe there's a way to do a ROS2 topic echo. That's not it. Oh, wow, okay. There we go. Okay. So the ROS thread is eating 87% of the CPU, even though hypothetically it's supposed to be using weights inside of the loop, but clearly it's not. Neither idle 1 nor idle 0 is running much. The LiDAR thread is eating 8% of a core. For all I know. Okay. Sweep thread. Large red self-destruct buttons. Well, this one doesn't have one, but... I wonder if I've done something wrong here. You know, I wonder... Big support timer Pico interop. End up pinning LiDAR. Oh. What if we pin LiDAR to thread 2? Just to, see what happens. Let's see if these statistics change any. Maybe we'll end up with 100% of main thread. Oh yeah, look at that. Main thread almost eats 100% of a core. LiDAR thread is completely stalled out. Let's not create any affinity there, see what happens. LiDAR thread has eaten 5-6% of a core, 89 on main. Interesting. Interesting. Well, interesting. All right, so really don't know what. Let's see. Wonder if I misconfigured something about micro-ROS. That would be my luck, wouldn't it? Like if it's not actually using the RTOS constructs, then it's entirely possible that a LiDAR task that's blocked on something could be stalled out, because if LiDAR task is sitting there in a spin loop with higher priority than the main task, then it'll never run. That was actually something suggested by that I saw was like, let's see, one thing I saw was, say, spin for, say, 90, what do you call it? I'm in the wrong area, sorry. One thing, I think I saw another site, do that and then vtask delay, for PDMS to ticks like 10. Like, free up, only operate at 90 out of every 100 milliseconds or something. It's something I saw in another thread somewhere. Maybe that'll do something interesting. Look at that. It's idling 71% of the time now. That's really weird. And it's publishing data. And yeah, this is publishing, the timer's working. What if we disabled that message? Sorry, LiDAR. Yeah, what if we disabled the RPM message publish? Do we get that crash that we did? Do we get that lockup that we did before? We don't. Ah, okay. So, what the heck? So calling, do you give, yeah, this is a PyPico 2. Yeah, so, okay, that's interesting. I saw, where did I see this? I should look at samples, right? So if the FreeRTOS apps micro-ROS, sample applications for FreeRTOS, I remember seeing in here, like ping pong, for instance, it would call, basically spin some for 10 nanoseconds and then, or spin 10 milliseconds, sleep 10 milliseconds. And so I didn't know why it was doing this. And I still don't know why. Like, presumably the way that I would implement one of these data distribution system things, right, would be if you have an RTOS under you that you can actually, you have events, you have threads, you have the ability to suspend execution waiting for something to happen, would be, if there was nothing to do, or, anything that could wake up your thread, or wait, that would get you to do something, like sleep waiting for those events to happen. And don't take up CPU cycles. Just basically say, here's the set of events that could wake me, and also a timeout. Wait on that. Give up the execution context. Let other stuff happen. So it really kind of bugs me to see this. Oh, call something and then sleep. Like if you've ever done any like event reactor type programming, like this is awful. It's like, okay, the U-sleep is what's basically this is going to busy loop for 10 milliseconds, and then you're going to give up the CPU for 10 milliseconds, rather than actually using a wait set of some kind. That's crazy. So concurrency issue, yes, sort of. More, I mean, not so much concurrency issue as because this was busy looping, it was either eating the whole core and not letting anything else happen, because there's a priority system. If there's the way that FreeRTOS scheduler, the way that the FreeRTOS schedule works is it's what's called a priority inversion scheduler. So in my table here of threads had said there's a main task. So idle priority is the lowest priority. So basically I had the lowest priority +1 was what the main thread's priority is. And then every other thing that we could do that actually handles data, I was setting as +2. So one higher priority than the main thread. Now, if the main thread was waiting on something, a resource contention from one of these higher priority threads, it would promote the main thread's priority equal or greater than it would promote the main thread's priority to the greatest priority of something that was I got that backwards. So if you have a task of low priority and it has a resource, it's locked a resource that a higher priority thread then waits on. It basically, the priority of the higher priority task is donated to the lower priority task, because the lower priority task is contesting a resource that the higher priority is currently in control of a resource a higher priority task needs. So that ergo, you should have the lower priority task have its priority temporarily promoted to equal to that of the thing that's waiting on it. But if it's not actually using a wait set, there's no priority constructs. If you're just busy looping on both sides, the main thread will never get execution time. But that's not even what we were seeing. We were seeing it eat 90% of a core, or 80-something% of a core. And now when we put this little sleep in here, we've only given up 10 out of every 100 milliseconds, and yet all of a sudden I'm idle for most of the time on a core. Which doesn't make any sense to me. Like, something, I really wonder. Alright, we're also gonna change this to PD MS to ticks 1. For tilt sweep task. Okay, we got rid of all that stuff. That's interesting. And actually, if we do, maybe I'm misunderstanding what this thing is. Maybe I'm misunderstanding what this RCLMS spin sum. I thought this was the time. Yeah, timeout nanoseconds. Checks for new data at the DDS queue as long as the context is available. Spend some checks one time for new data from a DDS queue. The timeout defined is 100 nanoseconds. The static let executor performs the following actions. Initializes the wait set with all handles the array executor handles. Waits for new DDS queue with data. Interesting. Okay, so what if we did cut it down to 10? Just like this apps thing shows. Anyway. You sleep, micro sleep, so 10,000 microseconds, 10 milliseconds. RCLMS to 10. Okay. So let's just copy. See what we got. And configure. And flash. Couldn't open the firmware. Okay, compile project. Oh, I have an error. Oh, oops. So now we're still doing that, right? I really ought to learn. I really, okay, well, you know, if it's still showing 5 hertz, that's fine. Why is it rotated though? It's not like the robot. Oh, the robot is kind of rotated. Save. Well, you know, that's interesting. Well, get rid of that anyway. Oh dear. Oops. Interesting. Yeah, there we go. Interesting. Okay. So, idle 0. Maybe I don't actually understand well enough what this, what this does. Or maybe, yeah, maybe I'm not understanding well enough. Honestly, we can, because this is a static function, right? We don't actually need it to be static. We don't need it to be 0 either. Stats. Size of stats. Yep. All right. And we're going to publish the FreeRTOS thread counters. Runtime statistics. Where perf. Call that firmware perf rather than anything else. We'll run this like once every 5 seconds. It's don't need to run it all the time. We're going to that's fine. Compile. I'm going to do it every 2.5 seconds. That's weird. Oh, I wonder if we blew a stack. Or if it's an asynchronous publish. Oh yeah. Well, it really didn't like that at all. So we're just gonna go back to using a okay, hold on. We're just gonna do a message equals dot static char performance runtime stats. It's going to be runtime stats message. This will be runtime stats, runtime stats. Data size capacity. All right. I got runtime stats, size of runtime stats. All right. Oh, oops. Oh. Stats message. Compile. There we go. Flash. Oh, it still didn't like that. I guess we do it every second. Oh, right, because I changed the name of the... Jeez. Firmware perf. Runtime stats. And honestly, I'll just call it firmware runtime stats. Firmware runtime. Firmware runtime stats. Laser RPM, laser scan. If we can just do this in here still. Yep. I'm gonna flash that. That firmware runtime stats. There we go. Publish that every 2.5 milliseconds. Okie doke. All right, so we're publishing the runtime statistics. All right. Perfect. And we're publishing the runtime stats. We're publishing this, so and I still, and let's actually just make sure that we didn't break our agent reconnection support. Yep, LiDAR powered down. We don't see anything here. If we power the agent back up, we should see it oh. Well, that's not what's supposed to happen. Okay, maybe we gotta flush the LiDAR buffer because I removed doing that. We got LiDAR speed, LiDAR, read pos is 0, LiDAR write pos is 0. All right, configure SWD. All right. We got usage stats. Going to kill the agent, see everything powered down, run the agent again, and hopefully we don't blow up. Yep, we're seeing runtime stats again. And all right. Perfect. Perfect, perfect, perfect. Okay. Looks like that's working really well. Another thing we could possibly do in the future too is, since this light is tweak the DMA loop that we actually let's try resetting this again. LiDAR spun down. We'll pin this back up. Sweet, it worked. Another thing that would be really interesting is what do you call it? Since we're using DMA to read the LiDAR data, it would be really interesting if we could use the DMA system, because right now we just read packets. We don't try to necessarily lock onto the LiDAR bit stream, the LiDAR like byte stream. We just transfer what would ever be the correct size of a LiDAR packet. The LiDAR sends one packet for every 4 degrees of sweep. But we submit it up to micro-ROS as a single assembled laser scan. So what might be interesting is if, rather than DMAing one LiDAR frame, one LiDAR packet, so 22 bytes or whatever at a time, if we DMA'd a whole laser scan and then processed it in one go, and then that would let us use essentially a ROS event callback rather than a thread. And you always want to minimize the number of threads if you can, but that'd be interesting. But the thing too is that I don't necessarily know how we're going to call it. We'd have to wake a thread. We'd have to push an event onto some queue or something to wake a thread, because how do we know that we're safely setting a flag from an ISR, like, kind of thing? You'd have to find out. But anyway, I do need to chop this up into multiple files at some point. Yeah, we can get rid of the LED. Actually, because we're doing what do you call it? We don't have the network stack anymore. We're just we don't actually have to affinity lock. I don't think we have to affinity lock the RCL thread. We'll call this the executor instead of the main thread. Compile. Flash. Oops, the agent's busted. Here, flash. Yeah. Admittedly though, the reason that this was a thing is that, or sorry, the reason that this was a thing was because with Pico W or Pico 2, Pico or Pico 2W, the wireless variant, the network stack needs to be pinned to Core 1. So that's where this was inherited from when we were porting over using my Pico balancer code base. But 40 bytes per task, so we had 10 tests before. Anyway, yeah, it's fine. Interesting. Idle task. I don't know. Okay. Well, either way, we can see that the executor has fallen to a very tiny amount of CPU load, which is kind of funny. I wonder what idle 0 is doing. Or what's tying up core 0? Okay, well, let's I'm actually going to start the debugger again. And we're going to let this run through and pause it eventually. See what happens. That didn't work. All right, Pico debug. Okay. Start the agent. Things fire up. Just going to give it a few seconds to settle. Yes, so you are okay. So I don't have a Pico W in here right now. It's standard Pico, or I don't. It's a standard Pico 2, right now. But when I swapped out the module in a stream, a couple streams ago, because the chassis doesn't need wireless functionality. It's just USB to a Raspberry Pi that can provide far better wireless. The oh wait, that's funny. Wait. It's not publishing. When I started with the debugger, it's not publishing. But yes, on the W, you would compete for state machine resources. Because one of them is used. Well, yeah, because one of them is used to drive the SPI connection to the wireless module, because they don't want to use, they decided they didn't want to use any of the onboard SPI controllers just to make them drop-in compatible for the most part with each other. Because on the Pico, not all of the Picos, not all of the RP2040 or RP2350s I/O pins are broken out on a Pico. And so what they did is on the wireless version of it, they used those non-broken out pins to connect to the wireless module. And, oh, why is it? All right, Heisenbug time. Or actually, attaching the debugger makes it not work. That's always fun. I can't believe the thing that made this start working was a random thing I remembered 3 hours in from another thing I had read. That's annoying. Oh well. Where is it stuck? Timer busy wait, get char. Ping attempts. Oh, okay. Well, it's oh, I killed the agent. There goes the LiDAR. But we're not publishing anything. But yet, if I don't start it with the debugger, I just flash it. crashed again. Okay, wait a second. What the heck? What's going on? Some funky happened. Yeah, there it goes. Okay. Wonder what's tying up core 0. Okay, somebody's really trying to get a hold of me. Okay. What's interesting is idle 0 is... Okay, I'm actually kind of curious to see what happens if we pin everything to core 1, just to see what happens with the statistics. Be kind of funny. Main thread, IMU task handle. Just curious. So yeah, idle 1, which should be core 1. Actually, let's assign tilt sweep to... Actually, let's just stop tilt sweep. Let's not even start tilt sweep because we don't actually have anything attached to it, so not do anything there. And let's assign, we'll assign the, no, we'll just keep everything at core 1 for now, just to see what happens. Yeah, I wonder why idle 1 is less than 1%. Unless it detected that nothing's running on it, so it turned off the core. Which could happen. Let's set the affinity here to a different core. See what happens. I wonder. I just don't know. I just don't know what it's doing, which is fine. Don't have to worry about it, really. As long as there's available time. Okay, cool. That's fine. That's fine. Okay. Well, all right. So we did that. We've got stuff running. We're reporting statistics. DMA. LiDAR's reporting. You can see the data. See our statistics. And data, you know, light, laser, RPM. Laser scan. That's fine. Okay. Either way, it's fine. All right, so we didn't get to the motion, but we did get performance stats, and we did get supporting reconnection to the agent. Yes, that's actually quite a good chunk of stuff to have done. Because, again, we didn't know how to implement that. Implementing sensor logic, implementing motion control logic is... we mostly know how to do that. It's not super learning work. So anyway, here we are. We've got this. I will try to clean this up and figure out what the heck I did to get so I can get this posted. But anyway, I'm gonna end the stream here. Thank you all very much for watching. I appreciate it. So next time we'll actually do the motion control. We'll actually do the encoders. We'll actually do reporting IMU status up. And then after that, we'll finally be able to actually start setting up nav2 and SLAM. So I'm going to